Hi all, we're going to look at doing the introducing probability. I'm going to run through it as if I was doing it myself as a student, so please feel free to follow along. Pause the video when we get to a question that you need to answer yourself if you want to have a go at yourself before I go through and complete it. Okay, so introducing probability. Step 1. How do we measure the chance or likelihood of something happening? So that's what probability is. Okay. Now, usually we can use real simple probability is based on a probability scale. You can see we've got 5 different steps here. If something's never going to happen ever, then it's going to be impossible, and it's got 0% chance of happening. Okay. If something is certain, it's always going to happen. It's never going to not happen. So that would be classed as being certain. And then as we go through. Okay, even chance. Don't use the word evens, unless on the end, because they'll mark it wrong in any test. You can put an even chance, it's a 50-50 chance, or 50%, or a half. Half of the time it's going to happen, half the time it's not going to happen. So with probability, you will see as we go through that you can use 3 different things. Sometimes you can use words, but most of the time ignore the words that's on where we've got at the minute and use percentage, fraction or decimal. So they're the 3 things ideally for probability that you're going to use. Now if it is on a probability scale, you're going to use the words like we've got here. Okay. Now the other 2 are unlikely. If it happens less times, if it happens infrequently, or if it doesn't happen more times than it does happen, okay, it's unlikely that it's going to happen. And likely, if it happens more often than not, it's going to happen. So if it happens 5 times out of 8, it's going to be likely that it's going to happen. Okay. So we're going to place the following events on a probability scale, and I'm just going to drag the arrows into the right place. So celebrate your 200th birthday tomorrow. Okay. So, while at times I may look it, it's going to be impossible. Okay, even if you do live to be 200, it's not possible. It's not your 200th birthday tomorrow, so it's impossible that you will celebrate your 200th birthday tomorrow. So I think that the oldest person I think we've currently got alive in the world is 112, 113. So it's not possible. Okay, if you toss a coin, you will get heads. So thinking about a coin, it's going to be an even chance, or 50-50, or half, because you've got a head and you've got a tail, so it's either or. Okay, so it's a 1 in 2 chance, which is a half. It will rain in Madrid on the 15th of August. Now, it's not impossible. Think Madrid's in Spain, so in August it's going to be quite hot there. So it's not impossible, but it is probably going to be unlikely. Okay, it's very hot and dry in Madrid, so it's very unlikely to rain. Okay, you can get closer down to the impossible area. Okay, but we're only using these 5 sections for now. It will rain in London on the 30th of November. It isn't certain it will rain. Okay, but it is probably likely, because in this country we do get quite a bit of rain in November. Okay, you will have something to drink this week. On that one, it's going to be certain. Okay, you've got to have something to drink at least every 3 days. I think you can only go 3 days without having a drink. This spinner will land on white. Now you can see we've got 1, 2, 3, 4, 5 sections. It's not impossible, but it is sort of like quite unlikely. Now, if you think we've got 1, 2, 3, 4 sections, so we're just a little bit lower than that, lower than that first unlikely. So, like I said before, we can get between these sections, and in this case, I've got 5 to choose from. So, if I cut this particular bar into 5 pieces, okay, that would be at each segment. Now on this one, I've got 6 numbers on a dice, and you get an odd number when you roll. So again, I could cut this into 6 pieces. Okay, but when I'm thinking odd numbers, I can have a 1, a 3 and a 5. So that's going to be half of the numbers on the dice. And the last one, you pull out a blue sweet from the bag. There's a few more blue sweets. There's 5 blue sweets to 2 white. So that's going to be, and again, if we split it up, if we go there, watch what happens. Your guess is too high. Okay, guess is too low. So it's going to be somewhere in between. There we go. So not quite to the likely, but it's relatively likely. Okay. Right, on to the next one. In this bag there are 6 sweets. Some are blue, some are white. What's the chance of picking a white one? Well, we don't know. We can't see what's in it. So we pick one out, it's blue, put it back in, pick another one out. We do it 10 times to start with. Okay. So we're going to keep picking them out. Unfortunately on this bit you can't fast forward this, so it does it at its own speed. So we're picking 10 sweets out. At the minute we've got 4 blue and 2 white, 4 blue and 3 white, 4 blue and 4 white, 4 blue and 5 white. So I've got 6 white and 4 blue. So I've picked my 10 sweets. So what's the percentage, if you like? What do you think the chance of choosing a white sweet is now? Well, if it was 5-5, it would be in the middle. But there's slightly more white sweets. So I'm going to say that it's slightly more likely to be a white sweet. Okay? So it may be true, but we still can't see. It's a guess. We can't see what's in the bag. So let's see what's in the bag. Now, so did you expect it to be that? Okay. The more goes that you have, the better picture you get. So the more reliable it's going to be if you actually have more and more goes. How many times do you think do you want to pick a sweet out of the bag? 100 times, 500 times, 1,000 times. Okay. 54 to 46. 231 to 269. 484 to 516. So again, you can see it varies however many times you're picking it out of a bag. And again, we would expect to see that 500, 500. 250, 250. 50, 50. Okay. So we're going to try and get this one. Match the pictures to the statements. Okay, it is certain that Ethan will take a white sweet from the bag, so that means that all of the sweets in the bags have to be white for it to be certain, so that's going to be D. It is unlikely that Ethan, unlikely means there's going to be less of a chance that they'll take a white sweet from the bag, so I've got to have less white sweets. So it's probably this one, B. And it is an even chance, so I've got to have the same amount of sweets, so it's got to be E. Here is another bag of sweets. Add or remove sweets to make the statements true. It is equally likely that I pick a white and a blue. So I've got to have how many of each? I've got to have the same number. So if I've got 3 white, if I take one away and I add a blue, I've got 3 and 3. Same number. It's impossible to pick a white. Okay, so let's go like that. No whites in that, it's impossible. It is very likely I get a white. Very likely. So I'm going to get rid of a couple of blue. Let's get rid of another blue. There we go. Next one. It is certain that I get a blue. They are all blue. It is very unlikely that I get a blue. So I don't want many blues this time, and I want a few more whites. Okay. And the last one. It is twice as likely that I pick a white as a blue. Twice as likely that I pick a white as a blue. So if I've got 2 blue, I need twice as many white as I've got blue. It's twice as likely. Okay. 6. Playing against a computer, roll the dice. The dice can land in 2 ways, on a 5 or not on a 5. If it lands on a 5, you score a point, otherwise the computer scores a point. First to 5 points wins. Okay. So who wins? Computer. Who wins? The computer. Who wins? I do. Who wins? Yee. Oh no. Your goal is 5. These are 5. Okay. Computer. 6. Computer. Okay, try it one more go. Roll it. Who wins? The computer does. I do. Computer. 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 Okay, now the computer's got 5 in 6 chances of winning. I've got a 1 in 6 chance of winning, so we would expect the computer to win most of the times. Okay, on the last page we played a game with a dice. If you rolled a 5, you got a point. If you didn't, the computer got a point. Was the game fair? No. There was only one way I could win, and there was 5 that I could lose. So you were very unlikely to win the game. It was unfair. How could you change the rules to make it fair? But you could say that odds I win, evens the computer wins. It's 3 of each. Or 1 to 3, I win. 4, 5 and 6, the computer wins. So there's many ways you can make it a fair game. Okay. For each of these fair games there is an equal number of ways to win and lose. Each player has an equal chance of winning. See if you can think of another game with the dice which is fair or one that is unfair. A lot of the time when you think about gambling, if you the reason that gambling is quite bad in the sense that a lot of the odds are in the favour of the people that earn the money. So that if you play a game of cards, for instance, then they usually put the odds against you. So therefore, it makes it really difficult to win. Thinking about the National Lottery, okay, I think there's a 1 in 13 million chance of winning the National Lottery. So there's a lot of chances you'll lose, but not many chances you'll win. Okay, I might have a chance just to do this. Let's see if we can roll this 20 times. This one does go a little bit quicker. Okay, so that's rolling the dice 20 times and it's recording the number of each of the outcomes. Okay. So, that's my outcomes. Look at the frequencies of the scores. I've got 2 1s, 3 2s, 3 3s, 4 4s, 3 5s, 5 6s. Is this a fair dice? Do you think the dice is fair? I would say yes. But it is hard to tell with this number of rolls. Now have a look. Is the dice fair? Well, it doesn't go on 1 very often. And these are quite fair, but look at the 6s. 208. So, over 1,000 rolls, I would say that it isn't that fair. It could be just by chance, okay, but we would expect over 1,000 rolls to be the same sort of number. If this was 170 and this was 170 as well as these, then we would say it was fair. Okay, but in this case it doesn't look like it's fair. So would you like to play with this dice if you had to roll a 1 to win? Okay, that's the sort of thing it's trying to get across. So you're looking to make sure that it's fair, and remember, to be fair, it's got an even chance of winning. So if there's 10 outcomes, you would have 5 outcomes that would win and 5 outcomes that would lose. Okay. If you want to have a look at the next video, there's 2 on probability and we go into a little bit more depth. Okay, thanks.